this is a this is an PCB of an air conditioner. If you can see the various components, this becomes your main PCB, this becomes your display PCB, your blower motor which runs your indoor fan, this becomes your transformer, and here are your connections for the sensors. There are two sensors, one being the room temperature sensor and the second being the coil sensor. First and foremost, whenever we go for the electrical connections of this particular kind of a PCB, if you have to understand the working, phase normally comes to this part which is called as the relay. Now if you have a look at the specifications of the relay, you can find 20 amperes 250 volts AC supply and there is 12 volts DC. Now that clearly indicates that this particular relay has got two terminals which can be seen in the video, and nevertheless on the other side there is an coil. Coil gets 12 volts DC supply, whereas the other connection is an electromagnetic switch. Phase is given to one of these connections, any one of these connections, and thereafter once this relay gets the 12 volts, the coil gets magnetized. Due to magnetic flux, this switch gets closed and contacts are made so that phase can go to the other side. The specifications of 20 ampere 250 volts AC supply is for this switch and 12 volts DC is for the coil. That's how you can see it on the particular relay. How do we come to know where should I put my phase or where should I put my other connection? The best and the easiest method for checking the same is by a multimeter. Connect the multimeter in the continuity. Check for continuity between my relay connections and the fuse. There is no continuity. That means my phase will not be fitting here. If I check on the next component, you can see that there is a continuity. Since there is a continuity and a beep sound, my phase supply will be given out here. From my power cord, I connect my phase supply to this terminal. Phase from here goes to my PCB. Thereafter it goes to my fuse. Via the fuse it goes to my metal oxide variator MOV, which helps the PCB against spikes, and thereafter this 230 volts is being given to my blower motor circuitry. So you can very clearly see my blower motor connections have been done out here, and there is a capacitor for my blower motor. This helps in starting up my blower. But we all very well know that this PCB has only received the phase. For any electrical device to be operational, we require both the phase as well as neutral. Neutral of the main supply is already been given to my PCB board. As very clearly you can see over here, it will be written as N. So this is where my neutral supply has been given. Once phase and neutral has been received by my PCB and I switch on the PCB, it will start to operate. Blower motor circuitry, since the blower motor works on 230 volts AC supply, this 230 volts is directly being fed to my blower motor. There is a parallel circuit which gives an input to my transformer. So if you can very well see, there is something written as TR in, transformer in. Supplies for the transformer are being given out here. This being a step down transformer, this being a step down transformer, 230 volts is given into this transformer, and the output would be as per desired. Very clearly we can see that there are two outputs given for this transformer. Okay, normally this transformer will have only two wires which will be giving a 12 volts output. As specified here, you can see that there are two voltages coming, 12 volts and 8.5 volts. 12 volt circuitry that is coming out over here is then been fed to my bridge rectifier, which is a series of diodes which converts AC supply to DC. So if I have to just summarize once again, phase comes here, from here it goes to my fuse, from my fuse it goes to my metal oxide variester, from there is a two connections, one goes to my blower motor, second goes to my transformer, and transformer output becomes 12 volts. So that's how 230 volts AC has converted to 12 volts AC. This 12 volts AC is then converted by this bridge rectifier into 12 volts DC. This DC still has got some kind of AC components. To filter them out, there are a set of bridge rectifiers that have been provided so that these particular AC components can be taken out from my DC supply. So these are my filter capacitors. At the end of the filter capacitors, what we get is a pure 12 volts DC. This DC is then fed to four locations. First being my buzzer, second being my swing motor. My swing motor of a split air conditioner works on 12 volts DC supply. The third component being my relay. As you very well read, 12 volts DC. As you very well read, 12 volts DC supply. And thereafter, the last components of 12 volts goes to my regulating IC, which is out here. So if you have a look from here, you will see the regulating IC number is 7805. The regulating IC number is 7805. 78 is for regulating IC and 05, the last two digit, talks about the voltage that will go in front. That means 7805, only 5 volts will be coming out. Similarly, if there is something called a 7808, we can come to know it's a regulating IC and 8 volts will be given ahead. And if it is 7812, 12 volts will be given ahead. So regulating IC is something similar like a regulator, which regulates the voltage. Thereafter, this 5 volts DC supply is being used by your remaining circuitry like your microprocessors, your display PCB, etc. works on this 5 volts DC supply. Now just to give you a glimpse, and if we come to our sensors, these sensors also have been provided by the same kind of a voltage. Okay. Now these sensors are negative temperature coefficient, that means NTC type sensors. So what does NTC mean? Whenever there is a change in temperature, if temperature reduces, resistance increases. Whenever a temperature increases, resistance will decrease, which clearly indicates that they are inversely proportional to each other. Right now, just for understanding, change in temperature will lead to change in resistance. If this is understood, we all very well know Ohm's law, which says V is equal to I into R. Voltage coming is fixed, 5 volts. Resistance value changes as per temperature. With a change in resistance, current value also will change. And it is this current value which is the feedback given back to my microprocessors. Okay, these microprocessors are already been fed by a software which talks about if a feedback of this current is coming, that means it is 24 degrees Celsius. So that's how temperatures have been recorded by sensors and are converted electronically, and that's how my display displays 24 degrees Celsius. Now whenever I on my AC for the first time, my room temperature sensor will be showing temperatures of a higher value, example 28 degrees Celsius. And if I have set my setting at 24 degrees Celsius, this sensor will give a feedback that the room temperature is 29. My microprocessor will be ready to start my compressor. But before he can take a decision of starting the compressor, he will ask for a feedback from the coil sensor as well. If my coil sensor says that there is no frost on my evaporator, only then will my microprocessor wait for the final call of the memory IC. The memory IC will show whether there is a 3-minute delay or no. If at all the 3-minute delay also is cleared, immediately my compressor will start. Okay. Now, how does my compressor start? I'll take you back to my initial page. Whenever my microprocessor feels or my IC feels that I have to start my compressor, microprocessor will give a signal to my IC. This IC will then provide 12 volts DC. This coil gets magnetized and this phase is then been given to my compressor. So the second terminal of my relay is going to be for my compressor or outdoor unit. Okay. So let us just make the connections of the outdoor unit. This particular supply that has been given back or return supply that has been given by the PCB is also called as CP supply by technicians. So that means main supply has come here, neutral has come here. That same neutral is been bypassed and given to my indoor terminal block. Phase from here has been given to my indoor terminal block. Whenever there will be phase and neutral supply, my outdoor unit will run. As you can very well see, at terminal 2 we are given the CP supply, that is for the phase, and neutral has been given at terminal number 1. When we start this particular AC at whatever temperature we have set it at, since the room temperature here is very cool, my compressor will not start. To help it take a start, I will reduce the temperature further. Normally 16 degrees Celsius is not advisable for the comfort of a human being, but since my ambience right now is being kept in air conditioner room and I want my compressor to start, that's why I am keeping it at 16 degrees Celsius. 16 degrees, power on in the cool mode. You can see that we have on this PCB in between, that's why it is taking a 3 minutes delay. This 3 minute delay is been controlled by my memory IC. It is this memory IC which basically talks about the 3 minute delay, and it also memorizes the settings that were been kept earlier, based on which in case if there is a power cut, it will start back with the similar settings.